Hello, everyone. Good morning. Can you see me? Can you see the screen? Does everything look good for y'all? Okay, perfect. So today we're going to talk about Python. And so, interested in starting your coding journey, let's learn the fundamentals of Python from installing a coding environment to making our first graph. So today, what we're going to go over is downloading a coding environment. We're going to try to look at different variable types, see what are they, what different variable types exist in Python. Not everyone's, but some of the ones that you're going to encounter a lot if you're interested in data science for Python. We're going to talk about some simple mathematical operators, and then we're going to get a little more advanced and talk about numpy, which allows us to do some more advanced math operations and allows us to introduce a fun new variable type, which I will motivate for you why we might need that a little bit down the line. And then the last thing we're going to do is look at matplotlib, which allows us to make graphs in Python. So because we're data scientists, I figured we might like to make a graph. And so that's the last thing we're going to do for today. And so who am I? My name's Rieker. I graduated Agnes Scott College in 2022 with a bachelor's in math. And I'm currently studying at Agnes, studying data analysis and communication. I've been a teaching assistant at Agnes Scott College and Upper Line Code. I've taught a little bit of physics, a lot of math, and some programming, mostly Python. And I'm from Atlanta, Georgia. Okay, so let's get into it. What's the best coding environment? So here's some options that we have on the screen. We've got Jupyter, we've got VS Code, we've got Idle, we've got PyCharm, all these coding environment options. So which is the best one? Well, coding environments are a little bit like a word processor. So if I wanted to write a scientific essay, I could open the Notes app on my phone and I could start typing it like that. I could open Word, I could open, a different word processor. I could do it in PowerPoint if I wanted to, but, it depends on what I'm trying to get done. So in our case, because we're data scientists, the coding environment that data scientists typically use is going to be Jupyter Notebook. And so that is a Python coding environment that allows us to have, it's got readable text that a human being can read, and we don't have to run every single part of our code in order. And so those are really useful for data scientists because sometimes we have these big old data sets that we import and we don't want to have that run through that whole import process every single time we want to make a little tiny error. And as data scientists, we want to put a lot of text in our files so that we can communicate with each other. So Anaconda is the download of choice for a lot of data scientists. Google Colab is good. And it can be a barrier to entry to actually download the coding environment. As I was doing my practice presentations, I realized that in some cases, if your internet's a little bit slow, it could take my entire presentation, and then now you've just only downloaded Anaconda. So I'm going to give you two options. I'm going to give you the link to Anaconda if you want to keep coding, you're ready to get into it. You want to download something to your computer, you want to run it, and I'm going to give you this thing called Jupyter Lite, which is what I'll be coding in because it's a little bit more limited than Anaconda. So I want to make sure that I'm using the most limiting software so that the people, if you want to use Anaconda, you shouldn't run into any of the issues that I might have using this Jupyter Lite. So I'm going to give you these two links and you get to make the choice. Do I want to run this in my browser? I don't want the whole commitment of starting to download things. Or do I want to download stuff? So Anaconda if you want to download stuff, and Jupyter Lite if you just want to click one link, and we're pretty much ready to go. Okay, so let's get into some coding. So I'm going to click the link that I put in chat, and I'm going to pull up this. It's going to pull this introduction up, and then I'm going to File, I'm going to go New, and I want a notebook because we're using Jupyter Notebook today. And then it is going to take a minute to load, and it's going to ask me for a kernel. And so I want to just click, yep, good. And Pyodide is a, for those interested, it just allows us to run Python in the browser. And if I don't do that, then Python can't actually run. Okay, so I'm going to change my notebook file, and I'm going to say, let's jump into Python. I'm going to rename it that. And then the first thing is I mentioned that we could write some text in here, so let's write a little bit of text. I want to do these two hashtag symbols to denote that it's title, and I'm going to say, let's talk about strings and variables. And then I'm going to click this run button, or I could click Shift, Return, Enter. You can check your keyboard shortcuts on the Help tab. They're going to be different for every computer. Well, not for every computer, but I'm running this on a Mac, so I know sometimes I have different keyboard shortcuts than you all. Oh, also, before I get too excited, I wanted to mention the format we're going to do this in is I'm going to lecture a little bit, tell you about something, and then I'm going to give you a 5-minute coding challenge, and I'll give you 5 minutes to work on it, and then post in the chat your answers. We'll talk about it a little bit, and then we'll keep going. That way, hopefully, I can keep you guys engaged. Okay, so strings. A string is denoted by these two sets of quotes, and I could type whatever I want in here. I can say, hello, I am a string. And then I can hit my run button, and Python's like, Python's upset with me. Uh-oh, don't be upset with me. Why are you upset about this? You're just a normal string. Maybe if I ask it to print this string, it'll be less upset. Pyodide, what's wrong with you? No, don't do this to me on the day of my presentation. Sure, let's hit restart. Maybe this will make it happy. Ah, is it the two eyes? Is this what you're upset about? Oh, goodness. If Pyodide and Jupyter Lite is upset with me, I will just switch over to the Anaconda install and pray that this works for you all. Oh, I tested it so many times. Okay, I'm going to switch over to my local install, and I super hope that this Jupyter Lite works for you all. There should be many options of browser Jupyter notebooks that you can use. This is just the best one that I can find. I'm so sorry I can't show you guys how this works in the browser. This is getting upset with me. And the reason I can tell it's getting upset with me is that usually when I run a command, it'll tell me the number of the command. Okay, let me move this to a different tab that you can't see so we don't all have to go through every file on my computer together. You have a typo in the print command. Did I fix my typo? It's working for you. Okay, excellent. All right, we don't need to go through every file on my computer, so I'm going to go to So if you had Anaconda installed on your computer, this is what it would look like. And you can see all my millions of practice presentations. So I'm going to go new file. And then I'm going to type, let's jump into Python. Let's try this all again. Strings and variables. Okay, and then I am a string. Please. Okay, there we go. So you can see we actually get something out. And our actual best practice with this is that we want to print, I am a string. And what a string is it's just like you know when you hang up those happy birthday banners and it's just a string of characters, it means something because we know how to read and we can interpret it. But Python is just like, okay, I have an I have a space, I have an A. It doesn't really necessarily derive any implicit or meaning from the characters. It's just like, I know exactly what this list of characters is. And you'll notice that I had to type out every time the words, I am a string. Oh my goodness, if only there was a speedier way that we could do this. Well, there is. We can introduce something called a variable, and that lets us store the information in our variable, and then we just have to type out the name of our variable instead of the entire string. So I'm going to say I'm string1, and then I'm going to say string1 is equal to, hello, I am a very long string that I don't want to type out again. I did not want to type this out again. Okay, and you'll notice it doesn't give us any output, but it did run. And so then I'm going to go, so I have to investigate. Did it work? Print string1. There we go. Look, it's printed out. And then print is exactly what it sounds like, you know, when you send a Word document to the printer and it prints it out, and then you have there on your little piece of paper the final output printed to the console. So that is our basics of a string. And so we're going to move on to our next. What if I wanted to make some changes to my string without actually sort of getting in there and retyping my entire string? So we've got string methods. All right, so we're going to go to, and I'll put this up on my screen, and then I will put it in chat for you all. So I wonder, what is the list of different methods that I can use on my string? So I'm going to look at this. How can I change my string without actually just going in and manually deleting every capital letter or something like that? Oh, okay, I could use this case fold thing. All right, let's give it a shot. Well, let's look at the documentation. It's always important to sort of check out, okay, the case fold method returns a string where all the characters are lowercase. Perfect. Here's the syntax. We need the string, and then we need dot case fold, and we don't have any parameters. A parameter would be something that we put in between these two parentheses. In this case, we leave them blank because we don't have any parentheses, but we still want to tell Python that we're trying to utilize a method. Okay, so I'm going to go string1. Isn't this so convenient? I don't have to type it all out again. Case fold, and I'm going to open my parentheses. And I better use my proper syntax and say print. And I can, did the link send in chat? I want to make sure you can actually see the links that I'm sending. That would be no good if you can't. Oh, for the shortcuts, previous web that I opened, Python commands. So this web page? Okay, I should have sent that in chat. Let me see if I can send it again and it goes through. Oh, it says, oops, I already sent that message. Okay, let's try. I hope you can all see that because you'll need it. If not, you can get to it by Googling string methods, and it's probably the first link. Okay, sweet. Okay, perfect. All right, I will continue. So sorry to pause like that. All right, string methods. Okay, so casefold is a method, so we apply it to the specific object in order to change the object. And then we have the parameters. And so let us try another method, one that uses a parameter. So we have, I will not go through the whole looking for it. I will just go right through it. It's going to be string1 dot split. And that is going to split our string up into It's going to assume that I want to split it up on the space, and it'll split it up into a list. And we'll talk about what a list is a little bit later. But basically, it's going to split it up into a bunch of individual strings. But let's say I don't want to do that. I foolish Python, assuming I would want to split it up on my spaces. I actually want to split it up on the lowercase I character. And so now it's split it up into 3 different strings and one very short one at the end here. But you'll notice that my uppercase I doesn't split on that, just lowercase I. And that is actually because Python it only does exactly what I tell it. So I'm telling it to do the lowercase I, and so it doesn't know that lowercase I and uppercase I have a connection because they're the letter I. It's just like, you've given me this character, I will split it up on this exact character. So that's something really important to consider. Okay, so I have our first mini lab, and I will set a 5-minute timer so you guys can give this a shot. And if you have any questions, I will be monitoring chat. So we have 5-minute lab number 1, and I will let you know that you might need to use that W3 Schools page. So I would like you to take the string, let's jump into Python, and I would like you to make it all caps, all lowercase, replace the lowercase t's with uppercase t's, and remove all of the spaces. So I'm going to put 5 minutes on the clock and give that a shot. All right, so that's 5 minutes. Okay, so we have one idea about how to replace. Okay, so let's try. I realize now I should have been more specific about that. So we have the string, we'll call it txt, is equal to let's jump into Python. And then we have one idea, which is txt dot replace, and then we have t with base t. Oops. And then let's print this. And then we have the idea of, oh my gosh, you guys are so on top of it. txt.replace. You didn't fall for any of my traps. You got it. Let's see how that looks. Yep, we've capitalized it and we've deleted all the spaces. Excellent job, guys. Excellent job, everyone. Okay, so let's move on to our next topic, which is going to be ints and floats. And let me make that a title. And so I can print, oops, let me spell print right, 7, and I'm not putting the quotes around it this time, and I can print 7.0. And these are actually 2 different things. They're very, very similar. And so when I do the first one is an int or an integer, so it's a whole number, and it actually has meaning. So it means the number 7. So it means 7 of something. It's not like our strings that we've been using before, which is just, it means a list of characters. And then our 7.0 is a float. So that includes every possible number, and it includes decimals, right? So I could go 7.89, I could go 3.1415. And so those are slightly different. And so knowing that, let's see if we can have any guesses. I'm going to type out something, and I'm going to ask what you all think will happen when I add this together. And I'm starting to think you might have some computer science experience here in the chat, and you might be able to get ahead of me and answer my trick questions, but we'll see. Oops. I've ruined my own question. Ignore that. Okay. I've hit Shift Enter by accident. 7 plus 7.0. Okay, so if you hadn't seen me accidentally press enter, what might you think would happen when I run this? How do you think Python will interpret this for these 4 lines of code? Do you think they'll all be the same? Do you think they'll be different? If so, how? Okay, you're on top of me. My trick questions aren't catching you guys. What do you think about the last one? Do you think it'll give us an error for this? Or do you think Python will let us do it? Will be different. Okay. How will it be different? Lines 3 and 4 are the same. Okay, I'm going to run this. And let's see if your guesses are right. Completely, totally, great job. So the reason that it prints 77 is because it interprets them as two different strings. So if I were to say yes, and then the last one, it automatically converted it to a float. So in other programming language, it might get upset that I'm trying to mix two different type of variables, and it wouldn't let me do that. But Python is smart enough to be like, oh, I know that those are close enough that I'm going to convert 7 to 7.0, and then I'm going to add them together. Okay, and so strings, technically they're not doing addition, they're doing concatenation. So if I do it like this, it might be more clear what's going on. So look, it just adds them together into one long string. That's string 1, string 2. All right, excellent job. So let's go over some operations. I think you will probably just know what these are already, but that's okay. So we've got our operations, and we're going to go x equals 7. We're going to go x equals 10. And I want you all to guess what will happen when or I will run this. And if you all could identify for me your guesses as to what operations Python is performing. And we have x. And so this is all the built-in operations. X. And you'll notice we have several things that all just look like division. So that's quite interesting. I wonder how they're different. Oh, and then fun and exciting. When I print something, I can add each one of these is like a parameter. So if I put a comma in here, it's like taking a new argument. And so instead of having to do this thing I did here where I print and then I hit enter and then I hit type print again, I can just do comma, 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 and it will know that I'm trying to print several different things with the same print statement. So I'm going to hit print on this. Well, that's a problem. So the name y is not defined is the error that I got, and it's always important. Errors are great. They tell us what's going on. And so the reason is because I forgot to define y. All right, so we print that, and we get 17, -3, 70, a very large number, 0.7, 0, and 7. Do you guys have any idea about what plus, minus, 1 asterisk, 2 asterisks, 1 slash, 2 slashes, or the percent symbol? What do we think that those are doing? Yes, I agree. Those two, this is raised to the power, this is division. You guys are so on top of it. Yep, this takes the remainder. And then what is this strange thing here that also looks like division doing? Do you guys have any idea? It is floor division. So basically it rounds down for us. So now we have our basic operations. We know what the basics are, and we can think, wow, if only we had more mathematical functions. Well, maybe my non-mathematicians don't think that, but I think that in my heart. And we might get some more mathematical functions later, because math functions are super easy to graph. So instead of having to import a ton of data in our super basic beginner Python tutorial, we can graph some mathematical functions. Okay, so next, let us talk about lists. And we have already seen lists. We've seen them over here. So I will copy this down to our section on lists. And this is exactly what I said it was before. It is a list of strings, which is very exciting. But lists can have anything in them. And that's the cool thing about lists. I can do 1, 2, oops, I can't do that. 2, string 1, I can put a variable in there. I can put a list in my list. What can I put in my list? I can put some 1, 5. I can put some numbers in my list. I can put some floats, and I can hit run, and it'll be like, yes, that's a list. Excellent work. And so this is very exciting for us. And so we're going to ask the same question that we Oh, I put last instead of list. That is not at all correct. And so we will think the same question we thought last time is, how can we edit if we have, yes, a list can include all type of data types. So if we were talking about things like booleans or other more obscure data types, yep, it can all go in a list, and it can have many different types of data. We'll see in a little bit something that's very useful to us, a type of variable that is similar to a list that's very useful to us as data scientists. Oh, and you will get a ton of data in the form of lists. So this is why we're talking about them, even though for our specific case study today, they're not the most useful, is that they can include any type of data. So this is very exciting to us. So we want to go list methods because we use them so often in data science. We want to be familiar today with how we might alter them, and we will be using very small lists because I don't want to make you type out really long lists of things. But when we're working with data, we could have a list with like 1,000 elements, and we can't just go in and manually find the thing that we want to change. So we're going to take a look at list elements, or list methods, pardon me. Okay, so I will make a list, and I'm going to call it, to really emphasize that we can have many types of data, I'm going to go 1, 2, 3, 4, and 5. And that is our list, and our list is, well, let me name it something more descriptive than X. That's the math list 1. That's the mathematician in me that wants to name things X and Y. Okay, so we can access any element in the list. Like if I know that let me ask you my trick question. I think you'll get it though. If I want to access the character 1, do I type list 0? So this will, or list 1, list 1, 1. So this is going to access the 0th element, and this will access the first element. And which of those two will give us the number 1? Do we think giving our 0th element or our first element? Yes, I think you may have some programming experience. Yes, we index at 0. So that means that when we start counting at 0 instead of 1, which is, if you've done programming before, very familiar to you probably. And so I will print these out, and this will give us 1, and then it might be counterintuitive, but when we put 1 in, that will give us 2. And so yes, you guys are totally correct. Great job, 0th element. Okay, and so now that we know that, and we know how to, if given the number of the element, how to access that element, let's think, what if I wanted to add an element without typing this entire thing out? So I'm going to look at my list methods, and I'm going to go to append, and I always want to check, are there necessary parameter values? Yes. In this case, the syntax of this is that I need to take my list, and I need to go dot append, and within the parentheses, I need to put the element I would like to append to the list. So in this case, I'm going to go list1 dot append, and then I will go 6 because that's the next letter. And then it says it's run it, but it won't output anything. So we better check. So we want to print list1. And there we go. And since we don't have to run things in order, if I actually go back and run this original line and then run this line here, it will redefine what I mean by list. And then when I run my print statement again, you can see that now it counts 21, 23, 24. I don't have to run my statements in order, but I run this again, then I run that, and we have 6 back. So remember, you can run things out of order, which is very exciting to us. Okay, so then what if I'm tired of my number 6. I want to go list1 dot remove, and then I want to remove, well, let's try to remove 4. I don't want that in there anymore. And I'm going to print list1. Oops, I got to type it correctly, and let's see. Yep. So this removal method will just go in and it'll snatch out the element that I type in here, that I specify. which is very cool. So if you had this incredibly long string of data and you knew one element was in there incorrectly, but you couldn't go in and actually find it because it was so much, you could just name the element and remove it like that, which is a lot easier. Okay, you can also redefine elements in a list. If I wanted to, let's say I'm tired of 2 being a string, I could go list 1. And we've already learned that I need to type in 1 there to call the element, and I could redefine it to be equal to 2. And then when I print list 1, just the same way that we were defining variables up here. Then when I print list 1, excellent, it looks like we now have a bunch of numbers here. So we're very excited by that. I can do math operations on this. I can also go list 1, 1 plus list 1, 0, and it'll add them together like normal. So even though we're typing in these variables, we can, Python knows that, okay, it will go into the list, it'll find it, yes, it's got a number, it'll pull that number out, pull the other number out, add them together. So that is very, very exciting. Okay, so our 3-minute lab, and you all, this is gonna require some copying and pasting. So if you can see where I'm going with this, refrain from utilizing any techniques I haven't taught yet. So 5-minute lab number 2. And our second 5-minute lab is, can you figure out how to add 3 to every element of, so we have a list and it's y equals 1, 2, 3. So can you figure out how to add 3 to every element without, while making Python do the addition work? Does that make sense? So we don't want to just type out y equals 4, 5, 6. We want to ask Python to do some addition for us. So I will put this in chat and I will start our 5-minute timer. All right, let's go. And so it will require you to copy the same code 3 times. And please let me know if you have any questions. I will be monitoring chat. Hi, Manny. I should have copied the assignment in. Let me know if you're able to see that. All right. Okay. You are all getting ahead of me, and you seem to have already figured out how to use for loops, which is great. And that might be the next thing we're talking about. But the solution I was going for was something like Adrienne posted, so I'll put that in here for us. So we have y equals 1, 2, and 3. But great job, everyone. I love the solutions I'm seeing. And then we have print y. And yep, that gives us 4, 5, 6. So great job, Adrienne, and great job to everyone who jumped ahead of me and realized, maybe there's an easier way to do this than just copying and pasting. If only there was. Let us. I have a great news for those who copied and pasted. As your classmates have figured out, there is a better way. We can use these things called for loops, for and while loops. So great work, everyone. Okay, so a for loop does the same thing over and over again a bunch of times, so we don't have to copy and paste. We can use loops. We use for loops when we know how many times we want it to repeat. So we're going to say we want you to repeat for 80 times. And that's when we use for loops. And we use while loops when we know that we don't know how long it's going to take or how many loops through our, how many loops it'll take, but we do know what we want the end condition to be. So I could say, while x is less than 10, keep looping. And then once that x becomes greater than 10, it stops looping, no matter how many times that takes. So there's some instances where for loops are good and some instances where while loops are good. So I want to expose you to both. And so I'm just going to illustrate for you what a for loop might do. So we have for x in range. And what range does is it will take 0 through 9. So the range of 10 from 0 to 9. And it will, we have to do the colon here. And then we want to print x. And so I will hit run because I think it illustrates itself better than just me explaining it. So it's the value of range is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then on the first loop, x becomes 0. And then we print it x, which is now 0. And then we go to the next loop. And we print, and x becomes 1. And then we print x, which is now 1. And it goes through again and again and again till the number 9. And so that's super easy, super clean. We also could, as some people were giving return statements, we could use return as well. In this case, I'm printing for ease of having introduced it already. But when you go out into the world of Python and you learn more, that'll be something you want to learn about. Okay, so can I do the same thing here with a while loop? I can. It's going to be a little clunkier though. So I want to start at y equals 0. And I want to say for y less than 10, print y. And then I have to make sure that I actually increase the value of y, or it'll just do this forever. So then I have to say y equals y plus 1. And for anyone who's familiar with algebra, that might look really weird. It might look upsetting to you. But what it means is we are redefining the value of y as the previous value of y plus 1. And so let's see what this does. Oop, syntax error. Ah, I see. I've forgotten the key element of a while loop, the word while. Okay, perfect. There we go. And so that gives us the same thing. So as we can see, we can accomplish the same task using for loops and while loops, but in some cases, for loops are more optimal. In some cases, while loops are more optimal. And so we can also do this with lists. So I might want to go to the grocery store. And I might say I need eggs, I need milk, I need bread, and I need butter. And then I can go for item in grocery, print item. And a key in Python is in some other languages, you'll have like brackets and stuff to denote what's inside of a loop and what's outside. But in Python, it's this indentation. So the indentation is, it's not just there to look nice, it's actually there to tell the Python what we're doing. So if I were to say print item and I weren't to include it in the indentation, what it would do is it would just add another butter onto the end of my list. And that's because by the time we get to print item, the only it will take the last value of item from the list, which is butter, because we've gone through eggs, gone through milk, gone through bread, gone through butter, and that's all in this section. And once we get to butter, the list is done, we can go on to the next thing. An item has been defined as butter. But if I hit this tab and I include it in our list now, we'll notice that it prints every single time as item changes. And then I'm realizing that my 5-minute lab for this one may have been thwarted already, because what I was going to ask you to do is for our next 5-minute lab, although I think we can just sit down and talk about this for a little bit instead of me giving you 5 minutes, because we're already talking about it in chat, is can you figure out how to add 3 to this much longer list? But since we were already utilizing for loops, I think we may have already figured out how to do that. So would you guys like 5 minutes to think about this, for those other than for those who haven't had experience with a for loop, or are you ready to just let it be done, let's talk about it? let's talk. Okay, so we're going to try this solution that Manny has sent us, and I will format it as I assume you so desire it to be formatted, and I will add it like this. Let's talk about it. Perfect. Okay. And so what Manny has gone ahead and used, and you can see this really great coding mindset of coming back to the problem and trying it again and again and again, which is really great. And if you're starting to get into coding, that idea of let me do one solution and let me try it again, let me try it again, let me change one little thing, that's super, super important in coding. And so let's see what this, oh, let me explain what length. So the length of y is that Python is going to, I will print for you. I will print the length of y so we can see what it is. So I'm going to comment this out for a moment, and I can use hashtag symbols to comment. So I want to print the length of y. And so the length of y is 10. What length does is it counts the total number of elements in the list. And so instead of us having to manually go in and count, which would be hard coding, which is not a great programming practice because then it's difficult to change later, we can put length of y as our argument for range instead of just the number 10. And that way, if I add more elements to my list, I don't have to manually go in and make it 11. And so let's see, I will comment this right out and let's see what happens. Okay, perfect. Oh, wait, okay. So here's one thing, is that this is printing it out in order, which is perfect, but it is not adding it to our list. So it doesn't send out another list. So do you guys have any ideas about how we could, because when I print y, right, y is still going to be the same. So, which is definitely how I set this up to sound. But if I wanted to make some z, and I wanted to make my z equal to y plus, how would I make a list z equal to y plus 3? Is my question for you all. Do you have any thoughts about how to make a list that is equal to y plus 3 instead of printing out the values? Although I definitely realized that the question made it sound like I wanted you to print the values out. Okay, let's try this. So let's try z of x equal to print. Okay, so we're getting an error. Z isn't defined. So what I can do here is I can go up here and I can define an empty list. And then we're getting the next error, which is for x in range length of y, list assignment out of index. Then outside the loop, print z. Okay, so let me remove this print statement. Okay, so what it's getting upset about is that there isn't a first element of z. So we could either define z to be the same as this, or we could change it to an append function here. Yeah, and that's another way that works, Nisha. Okay, this is so great. Look at all these different solutions. I will show some on the screen because we are all, a really important part of coding is that the way we can all, yes, exactly, Rick. Z doesn't exist because the list is null. So we either have to use this append, like Nabil suggested, and you can really see here what the fun thing about coding, which is that there's so many different solutions to the same problem. Okay, let's try z plus, let's try y of x plus. Let's try z dot append y plus 3. I can only concatenate. Oh, y of x plus 3. Because it was, there we go. Oh, because I would need to define z as an empty list here. There we go. And you can see, have I made some terrible mistake? Oh, right, because I redefined y in the last problem. And I'm forgetting about being able to run Python out of order. So we can see here, there's a lot of different ways to get to the same exact problem, to get to the same exact answer, which is super exciting. And so great work, everyone, coming from different methods to figure this out. Okay, and the next thing, don't we wish there was some way to add to a list of numbers without having to go through this? And the reason that we wish that is because if we were to graph something and we needed to, if we were to have like x-axis data and we needed to shift it all over by one, we would have to not concatenate. We'd have to go through every single one of our x data. So what if we could just directly add to the list? And that's where we get into a new type of variable. And we get into a new Python package. Okay, so the name of this Python package is called numpy. And we're going to, or it's a library. And a library is basically, it has a bunch of new sort of features and commands that the core of Python doesn't need, because the core of Python needs to be lightweight, it needs to be ready to go. Not everybody is as passionate about me as adding numbers to lists. So it isn't included in the default. And this also allows us to get to some more advanced mathematical functions, which we might want to try to graph. Because those are super easy to graph compared to some other types of data. Okay, so we want to get this in, go find this library by saying import numpy as np. And np is an abbreviation. So numpy is the name of the library, and then np is an abbreviation that we can use. So every time we call for the library, we only have to type 2 characters instead of typing out all of numpy, or numpy, depending on who you are and how you pronounce it. And it's going to take a second to load because it has to grab all this data from somewhere else. And so we have a new type of variable, and that's arrays. And we can go numpy.arrange, and we can go 50. And there are different parameters that this arrange can take. In my case, I'm leaving some blank because they are optional, and I'm just it's going to create a list from 0 to 50. And so it's kind of similar to a range function. But the special thing is that I can perform operations on it. And it's quite similar to a list. So if I wanted to say z is equal to np arrange, and I could actually, if I want to not my first number not to be 0, I can specify it. I can say it's 1. I want my last number to be 50. And this is too many numbers. So I want to go up in steps of 10. And so, and I add extra r's, and then I'll print these so we can see what it is, right? And so I'm starting at 1, ending, I want my last number to be less than 50, and I want to go in steps of 10. And then, super easy, I can redefine the list by going z plus 3, and then I print z again. And now we don't have to go through and tax our computer so much going through again and again and again and again. We just do a basic addition. And then we also have, numpy also allows us to add random. So if we end up with a bunch of time left over at the end, I'm not sure that we will, but if we do, I can show you how to create random sets of data, and then we make a bar chart. That's fun and exciting. That's also an extension that you could go look up after this if you're now very excited about Python. So we've got np.sign, and this may, we're doing a throwback back to in my practice presentations, my peers informed me that not everyone thinks about sine and cosine as often as I do. So this is less exciting for some than it is for me, but I love sine and cosine. And so it allows us to do these more advanced mathematical functions. And so we can perhaps create a graph. And so in order to set this up, our next 5-minute challenge is that I would like you to utilize what we've just learned in numpy, and I'll do our 5-minute challenge. And I'll set the timer. 5-minute challenge number 4, I believe. And I would like you to, for no particular reason, definitely not related to me introducing graphing right next, is I would like you to generate one array, and remember this is how you generate an array, with the named X with the values 1 through 50, and another array named Y that takes the sign of 1 through 50. All right, I will copy that in chat in just one moment, and let's give it a shot. And we will be potentially using that as our X and Y data for our first graph. So I will start this 5-minute timer. And I'm happy to answer any questions that you might have in the chat. Yes, absolutely. Once we get to the end, I will either send that in chat if it'll let me send files, or we've got a minute left. So I just wanted to give you a minute heads up, and then we will talk about how we did this. All right. I see some answers already, so let's give a shot to our first answer and see how it imports. And we have print x, and then we have y equals np dot sign of x, print y. So yes, we have some good instincts in the chat, right? Because this one doesn't go all the way to 50. We better set the step to 1, and we better make sure that it goes to 51. And then, wow, look at that. It includes the numbers 1 through 50, and then it includes some sign information for all of them. And you can see that the method with the iteration is absolutely a way to do it, but what the super great thing about arrays is we can apply like the sign function to the entire array instantly, and then we don't have to iterate through it a million times, which is great, and it puts a lot less strain on our computer. Okay, so now we have our data, we have our X, we have our Y. I think you all know what that means. It's time for our first graph. And so let's get into matplot. Or it's not actually capitalized. I always think it is. Matplotlib, which is a library for plotting anything that you could want. And let me actually look it up and show you some of the things that they can do in Matplotlib, because I feel like you'll get excited about this. I don't know, you seem like a type of group that would want to be able to see the potential final end goals that you could extend. So I will show examples. And we will start with something much, much simpler than this. But look at all of these graphs that you can do in Python. I just wanted to briefly scroll through because you seem like a group that would enjoy knowing where you can go with Matplotlib. Okay, let's get back on track. Okay, so we want to import matplotlib.pyplot as plt. And isn't it so great we can do that so we don't have to type out matplotlib.pyplot every time we need matplotlib, and then it'll take a second to import it, and now it's imported. Okay, and we can do plt.plot x, y, and then because we've defined x and y, and then we want to do plt.show to make sure it shows the graph. And we always want to end with plt.show because I believe it won't run anything after plt.show. I'm not 100% sure. And there we go. We have our first graph. And it looks a little bit janky. And we're so sad about this. Why? Why does it look so janky? Well, we can go to the documentation of the np.sign function. np sign. And this is a good practice in Googling and looking things up. We can look at it. And we can go, why are you behaving so oddly? Okay. Oh, okay, the angle in radians. 2 pi radians is equal to 360 degrees. Oh, so we're saying 1 radian, 2 radians, 3 radians. Well, I'm not a fan of radians. I want these degree things. So I can instead say that my y is now equal to, and I will just type this in so that you don't have to, or that my new x is equal to 180. I'm not doing floor division, pardon me. Divided by 180 times 3.1415. And so that's how you convert from radians to degrees. which my classmates have let me know is not as exciting as I think it is. And then we have y equals sine x. And now we have this beautiful, and let me go grab this up here so that I can make our life easier for us. And we can actually delete this one because it'll automatically assume that I want steps of 1, which is very exciting. Okay, so now we have this strange line. Oh, well, that's because we don't have a large enough range. So let's add a 0 to the end of this. And now, the larger we make our data that we generated, in this case, we can see more and more of a sine graph. And so that is super exciting to us. We can, let me see, do we have a 5-minute? Okay, yes, we do have 5 minutes. Okay, so we can color equals B, and that changes. No, I see, I've typed that in the wrong spot. I'm a fool. It goes over here. So color, so we can edit the, or we could say red, because there's a full list of colors that matplotlib has. And we can edit the attributes of the graph in this plot.plt, and now our line is red. I can also plt.x label, and I can set that to be equal to time. And now we have a beautiful label on the bottom. And then I can set plt.y label to be equal to frequency. And then we have frequency on the right. And I could also say, I want my plt.y ticks. I'm upset that we can only see so little of the sine graph. I want them to go from -2 to 2. Oh, why are you upset at me? Ah, haha, of course, because I've just put in 2 and -2. It needs an array for the ticks. And so you can see that we can add a lot of customization to our graph. Oh, right. And then it doesn't include the top value. So I better include 3 in there to make sure that I'm getting everything up to 2. Okay, so here is our example graph. And then our last, we have about 15 minutes of the class left, and I want to leave some time at the end for questions. So our last 5-minute coding challenge is that I want you to, and this is going to be a little bit of a creative one because we're getting into graphs. So our last 5-minute coding, lab number 6, question mark, is I want you to make a graph. I want you to choose a mathematical function because those are super easy and we know how to do them. And I want you to graph it. So if you're feeling challenged already by just the concept of graphing, maybe you can generate an X and a Y that are a straight line. If you're feeling confident, you could go through the numpy documentation to practice this searching through documentation element, and you could find a mathematical function that's different from sine, and you could graph that. And so that is our last 5-minute challenge that I have for you. And then if you share in the chat, I will put it up on the screen so we can all see what everyone has done. So let me start the timer on that and give you 5 minutes to make a graph. And if you have any questions, if you need me to look up how to change, maybe you need some grid marks and you want me to go check the matplotlib documentation to figure out how to do grid marks or something like that, please let me know. Happy to answer any questions. If you want to send the code that you've put in so far, I might be able to help you troubleshoot why it's not showing the line. Or do you mean that when you typed in the same code that I had, it didn't type it in? Oh, how interesting. Is this in... Right, I can't get this to run properly. Are other people who are working in this Jupyter Notebook Lite able to see graphs? Almost that is busy. Okay. And you're, let me make sure. PLT works for me. PLT. Oh, okay. So if you're working in this one, I was trying it out this morning, and that is because you have to put plt.show or I don't have to. Anaconda is smart enough. This particular Jupyter notebook is smart enough to know what I mean. But Jupyter Lite gets upset if you don't put plt.show at the end. So that should fix that. I think I think I got that error this morning. All right, that is our 5-minute timer. Could those of you who made some graphs for yourself share the code that you got, and we can all look and see what creative things you've done together? You have PLT. I am not sure what the issue is on that first one with your issue, Samina, because that should work. And I don't know why it does not want to show you a graph. I think I may have recommended you a kind of finicky coding environment to work in. So I'm very sorry. And you've made sure that you've imported, well, it would give you an error. Okay, let's take a look at these graphs. That is an excellent parabola. Okay, and then we've changed the color to blue. Very cool. And we've changed it from frequency to freak. And this is, oh, and it's cosine. Okay, great. This is super cool. So I will keep showing on the screen any more that come in, but I want to make sure to be respectful of your time. And so that is all I have. Wait, okay, before I be respectful of your time, I do have some recommendations for further learning if you were excited by this and you want to keep learning. And then let me also give you the link to my file as well. So there are a ton of online resources. So Packet allows you, it's a $10 a month subscription to get access to textbooks. And so, you know, when you like order a coding textbook and then the next year it's outdated and you have a physical copy, but it's already outdated. I definitely use Packet. There's like $10 a month subscription to get all the textbooks. And then there's so many great tutorials on, oh, let's look at this tangent graph. I'm so excited. I'm sorry for making you all do math. There's so many great, this is super cool. There's so many great resources on YouTube. I was looking up a ton of resources to make sure that I knew what I was doing with matplotlib. And then Harvard has free computer science classes. So if you're ever like, I need more of a class structure, you could always take a course at Harvard. Coursera, if you click through, you can actually audit the classes for free. And there's so many great coding resources. If anything that I've been talking about today has been interesting to you, I highly recommend putting into Google or into YouTube the name of that thing that was interesting. You could do lists. You could say list Python for beginners or something like that, and then continue your coding journey. Thank you all so much for coming to my presentation today and being willing to type in chat and engage with me. I hope that you have you've made such excellent graphs. So thank you all. I will be here for the next 5-10. Yes, I just shared my LinkedIn in the chat. You are so welcome to connect with me and answer. I'm happy to answer any more questions. I will stay here for a little bit. Oh, wait, let me get that Dropbox link. I will not forget. You asked for it and I will go find it. So I want to copy Dropbox link, and yes, thank you for keeping me honest with that. That should link you to, yes, that should be an IBP dot, yes. And this is, okay. So hopefully that works for you all and you're able to download it. These are such fun graphs. I'm so proud of you all. Thank you all for coming.